In this lecture, we're going to talk about the fundamentals of making an economic decision. In particular, we're going to cover three topics. First, we're going to illustrate a very fundamental choice through a numerical example in which we'll demonstrate that the choice is a trade-off between benefits and costs. Then we'll develop a more formal approach and some notation for making an economic decision. And last, we'll introduce a very basic decision criterion called prospective benefit and prospective cost. Let's start first with a very simple numerical example to illustrate the fundamentals of making an economic decision. Let's assume we have the following situation. Let's assume that you could subscribe to a magazine and that a one-year subscription costs $20 and a two-year subscription costs $35. And as a special offer, these prices are guaranteed for the next 4 years. Which would you prefer? Well, let's translate this problem into its net cash flow series. That is, the cash flows that describe the choice between a one-year subscription for the next 4 years versus two two-year subscriptions covering the next 4 years. And that would look like this. We have the following choices. We have two alternatives. We can either invest in the subscription 1 year at a time, in which case it will cost us $20 at time 0 for the first year subscription, $20 at time 1 for the next year, $20 at time 2 for the next year, and $20 at time 3 for the final and fourth year. Or I could subscribe for two two-year periods, each costing $35. Now, in an earlier lecture, we discussed some basic principles of doing an engineering economy study. And one of those principles was that decisions should be based on the differences. That is, in the choice between a series of one-year subscriptions or two-year subscriptions, that decision should be based on the differences between those cash flows, which I can write this way. If I take the difference between two two-year subscriptions and 4 one-year subscriptions, I end up with this cash flow stream. That is, do I spend an additional $15 at time 0? That is, regardless of my choice between the one-year subscription or the two-year subscription, I'm going to spend at least $20. In the decision between those two, the question becomes, do I spend an additional $15 for the two-year subscription? To save or to avoid spending $20 at time 1, but it will cost me an incremental $15 at time 2 to save $20 at time 3, and there is no cash flow consequence at time 4. Fundamentally, my decision here in the choice between a two-year subscription versus the one-year subscription is a decision as to whether I accept or reject this cash flow series. If I accept this cash flow series as being an economical choice, then I prefer to have the two-year subscription. If I reject this cash flow stream, then I prefer to have the one-year subscription. How do I decide whether I should accept or reject this cash flow stream? To do that, we need to identify what are called the benefit cash flows and the cost cash flows. Here again is my incremental cash flow stream that I identified on the preceding slide. And what I'm going to do now is to break it down into its component elements. And there are two elements. We will identify all of the positive cash flows, that is, the savings, as the benefit series. And all of the negative cash flows as the cost series. In the decision as to whether I accept or reject this incremental cash flow stream, depends on whether I would prefer to have the benefit series or the cost series. I can have one or the other, but not both. Specifically, if I prefer to have the 2-year subscription, what I'm saying is I would like to save $20 at time 1 and $20 at time 3 and give up the opportunity to have the $15 at time 0 and the $15 at time 2. On the other hand, if I prefer to have the series of 1-year subscriptions, then what I'm saying is I prefer to have the cost series. That is, I prefer not to spend an additional $15 at time 0 and at time 2, and I will give up the opportunity to save $20 at time 1 and $20 at time 3. The fundamental choice we have here is a choice between, do you prefer to have the benefit series or the cost series? You can have one or the other, but not both. If I prefer to have these savings, then I give up these cash flows, and I should accept this incremental cash flow stream and take the 2-year subscriptions. Alternatively, if I prefer to have this cash flow stream, that is the cost series, to have these cash flows available to me at these points in time, then I give up the opportunity to have the benefit series. I should reject this incremental cash flow stream, and I should choose the 1-year subscriptions. Now, in the choice between the benefits and the costs here, what we have are 2 vectors of numbers. And we've got to decide would I prefer to have $20 at time 1 and $20 at time 3, or would I rather have $15 at time 0 and $15 at time 2? Now, presumably, when these funds are available to us, that is, when we save the $20, for example, at time 1, those funds could be invested or remain invested if they are so already invested. And if we do so, we could invest those funds at some interest rate, and they would accumulate to some future amount. Call it F sub D. Alternatively, if I choose the cost series, I could invest these funds rather than invest them in a magazine subscription. I could invest them at some interest rate, and they would accumulate to some future amount. Call it F sub C. The question then is, would I accumulate more by investing these savings to an amount F sub B, or would I accumulate more by investing these to accumulate to F sub C? It's basically an equivalence calculation, and we can write that this way. Let's assume that you can invest at 3% per year. If that were the case, then the future amount of these $20 invested at 3% per year can be written this way. It's $20 compounded forward at 3% per year for 2 periods, and we add in the $20 at time 3, and you would accumulate $41.22. Alternatively, we could invest this cash flow stream, and we could write it this way. It'd be $15 compounded forward at 3% per year for 3 years, plus the $15 at time 2, compounded forward 1 period. We do that calculation, and it works out to be $31.84. In other words, investing the benefit cash flows, the savings here, at 3% per year would result in an accumulation of $41.22. Whereas investing these cash flows at 3% per year would accumulate to $31.84. The decision should be fairly obvious. Clearly, we are financially better off by having this cash flow stream and not this one, because we'll accumulate $41.22 by having the benefit series, whereas by having the cost series, we accumulate only $31.84. So a good economic choice would be, given that the future amount of the benefit series exceeds the future amount of the cost series, We prefer the benefit cash flows, which means we should accept this incremental cash flow stream. It is an economical course of action, which means choose the 2-year subscription. What I have shown here is the fundamental basis for a number of economic decision criteria that we're going to introduce in this course. I've simply done so in a numerical fashion, but they all are predicated fundamentally on this choice of benefits versus costs. What I want to do now is develop a more formal representation of this decision process, and we'll do so in the following fashion. First, let's talk about an economic decision criterion. An economic decision criterion is a procedure that we use to make an economic decision. A decision criterion is comprised of 2 components. It's comprised of a measure of worth and a decision rule. Let me give you a non-economic example of what we mean by a measure and a decision rule. I stand exactly 6 feet, 0 inches tall. I'm precisely 6 feet tall. That is my measure. I stand 6 feet. If I ask you the question, am I tall or am I short? That depends. For that, we need a standard. We need something to compare my measure to. If I use, for example, the average height of an American male, I would be tall because the average American male is somewhat less than 6 feet. If I choose as my standard, say, the average height of an NBA basketball player, then I'm short because their average height clearly exceeds 6 feet. The role of a decision rule is to help us judge or evaluate this measure. The measure of worth in an economic context simply expresses a monetary value associated with an investment alternative. It's the decision rule that helps you judge whether or not that particular value is an economical course of action or not. Let's introduce another concept. Up to now, we've been talking about an interest rate I. Now we're going to start associating with that interest rate a very special meaning. Now we're going to talk about an interest rate called the minimum attractive rate of return, and it goes by a number of names. Sometimes it's called the marginal growth rate, sometimes it's called a discount rate, a cutoff rate, a hurdle rate, a yield, among many, many others. The minimum attractive rate of return represents those opportunities that are readily available to us to invest our funds. It will become our minimum standard by which we will compare our alternatives and our opportunities. That is, it represents opportunities in which we could invest our funds if we were to not invest in the opportunities presented to us. Perhaps the best thing to do here is to give you just a little example to illustrate what we mean by the role of a minimum attractive rate of return. For example, let's assume you had an opportunity to invest $100 today, and that 1 year from today, you would get a return of $105. Obviously, at this point, you ought to be able to recognize that the effective interest rate on this investment is 5% per year. That is, by investing $100, you will get a return of $5 in 1 year. Question, is this an economical investment? Now bear in mind, the 5% simply tells you what you're earning by investing in that opportunity. But it doesn't tell you whether this is an economical course of action or not. For that, you need a standard. You need a basis of comparison by which to evaluate whether 5% is a good investment or not. That is the role of the minimum attractive rate of return. If our minimum attractive rate of return, that is, the opportunities that are readily available to us to invest these $100 if we did not invest in this course of action, if we invested them somewhere else, and we could invest elsewhere at a rate that was less than 5%, then clearly that would be an economical course of action, rather than invest in our minimum attractive rate of return that might be, say, 3%, taking those funds out of that and putting it in this investment would be a profitable course of action. Alternatively, if my minimum attractive rate of return was greater than 5%, say 7 or 8%, then this would not be an economical course of action. We would not take those funds out of our minimum attractive rate of return and invest them at a lower rate of 5%. That's the role of the minimum attractive rate of return. It sets the standard. It helps us to assess and evaluate whether or not a particular course of action, in this case, this opportunity, is an economical course of action or not. Well, what are some of the values that a minimum attractive rate of return might take on? Well, that sort of depends. For most of us as individuals, the minimum attractive rate of return typically represents those opportunities that are available to us in the money market. Often, those values would range somewhere in the increment of about 3% to maybe 10%. For corporations, on the other hand, the minimum attractive rate of return represents the opportunities, the minimum attractive opportunities in which to invest in that company. Now, from a stockholder's point of view, hopefully it makes sense to you, that a company would not set its minimum attractive rate of return equal to what it could get in the money market. As a stockholder, why would you invest in a company that's producing a return no better than what you could do yourself in the money market? For most corporations, the minimum attractive rate of return typically is greater than what you could get in the money market. A typical range would be something on the order of, say, 10% to 15%, in some cases maybe as high as 20%. In either case, the concept is the same. That is, the minimum attractive rate of return represents the minimum attractive opportunities that are readily available to you to invest your funds, and it represents the standard by which we will compare our opportunities. Some more notation. Up to now, I've been giving you some cash flows in a numerical representation. Now we need to be able to do so in a mathematical representation because we want to develop a more formal approach to this. Now I'm going to introduce the symbol AJT to represent a net cash flow at a given point in time. And I've underscored the word net. By net cash flow, we mean it is the sum of all the receipts minus all of the expenses at a given point in time. I'm going to let the symbol J, lowercase j, represent an index in opportunities. That is, to help me identify and keep track if I have more than one opportunity. And the index could go 1, 2, 3, or A, B, C, or A1, A2, A3, whatever. It's just an index to keep track of the individual opportunities that I'm being presented. We will let, by sign convention, we will let AJT be greater than 0 when we're talking about a net receipt, and AJT will be less than 0, that is a negative number, for a net expense. And by definition, we will let AJT be equal to 0 for all times prior to time 0 and time n, where time 0 and time n now take on a special meaning. Time 0 will represent our decision time. It's the point in time at which we have to make a decision about an opportunity. It does not necessarily mean there'll be a cash flow at time 0. All the cash flow consequences could occur at some points in time into the future. This just represents the point in time at which I will make a decision, and all the consequences of that decision will occur after that point in time. Time n will represent the planning horizon. That is the period of time over which we estimate all of the consequences associated with this decision will occur. Specifically, anything after time n, there is no consequences. Anything of consequence to the decision will occur between n and 0. And we will let the net cash flow stream be divided into its two components, which we've already discussed. That is, a benefit cash flow series and a cost cash flow series, where the benefits are identified as those net cash flows which are greater than 0. The cost cash flows will be all of those net cash flows which are less than 0. Let's develop a basic decision criterion. It's called prospective benefit and prospective cost. I said that an economic decision criterion is comprised of two quantities, a measure of worth and a decision rule. So let's represent the measure of worth this way. The measure of worth for prospective benefit is the sum of all of the benefit cash flows compounded forward to time in at the minimum attractive rate of return to a common point in time, call it capital T. The prospective cost is the sum of all the cost cash flows compounded forward from time 0 through time n to a common point in time, capital T, at the minimum attractive rate of return. Now, this is the most general representation. Typically, the point in time to which we compound these cash flows will either be time 0 or time n. In other words, this basically says find either the present worth of all the benefits and the present worth of all the costs, or find a future amount of all the benefits and a future amount of all the costs. Now, we said every criterion has a measure of worth and a decision rule. And so the decision rule for this criterion should be if the benefits exceed the costs, then we should accept. That is, we should prefer that alternative. It is an economical course of action. If the costs exceed the benefits, then we should reject. That is, we would not prefer to have opportunity J. Let's take an example. Let's assume we have the following situation. Let's assume we have a manufacturer who's considering the purchase of 10 robots to spray paint its product as it passes along on the assembly line. Each robot costs $200,000 and has an expected life of 9 years. The cost to install all of the robots, not each one, but all of them, is $45,000. Each robot is expected to reduce labor costs by $50,000 a year, but it will increase our energy costs by $15,000 a year. Let's assume our minimum attractive rate of return is 10% per year, and the question is, are the robots economical? What we need to do is to translate this information into the net cash flow series that describes my choice. It would look like this. Here is our original problem data. Here are our increments of time going from time 0, the decision time, to our planning horizon, 9 years. In this particular problem, we said we were going to purchase 10 robots. They would each cost $200,000, and it would cost us $45,000 to install them. Therefore, the total net cash flow at time 0 would be an investment of $2,045,000. For that investment, we would have 10 robots. They're going to have labor savings of $50,000 a year, but increased energy costs of $15,000. So the net cash flow, the net savings I would have every year for the next 9 years is $350,000. Basically, my choice is this. Is it worth spending $2,045,000 to save $350,000 each year for the next 9 years? My choice here boils down to a choice between benefits and costs. Here again, I have shown the net cash flows that we just calculated, and then I've identified the benefit cash flow series and the cost cash flow series associated with the decision to either accept or reject this cash flow stream. Specifically, my choice is this. If I choose to install those robots, then I choose and prefer to have the benefit stream, meaning I prefer to give up the opportunity to have $2,045,000 today to spend on something else besides the robots. I give that up because that will be invested in the robots. To have $350,000 each year for the next 9 years. Alternatively, I can give up this cash flow stream, that is, do not install the robots, which means I prefer not to spend $2,045,000 today and instead invest it elsewhere, not in the robots. That's my choice. I can either have the benefit cash flow stream and give up the cost cash flow stream, or I can have the cost cash flow stream and give up the benefits. If I choose to invest in these robots and I choose to have the benefit series, then as I receive these savings of $350,000 each year for the next 9 years, presumably I can invest those funds and they will accumulate to some future amount. Alternatively, if I reject the benefit cash flows, I prefer instead not to invest in the robots and have instead the $2,045,000 to invest elsewhere. That would accumulate to some future amount. And I can calculate those amounts as follows. If I find the future amount, what we will call the prospective benefit of this benefit cash flow stream, that is $350,000 times my equivalence factor, find F, given A, at interest rate I for 9 periods, results in 4752.8. That is, if I were to invest these cash flows at 10% per year for 9 years, I would accumulate during that period of time, by the 9th period, I would have $4,752,800. Alternatively, I could instead choose the cost cash flow stream, that is, invest not in the robots, but invest this at 10% per year, and that would accumulate to take $2,045,000 times my equivalence factor, find F given P, at 10% interest for 9 periods, results in $4,822,000. Which would I prefer? Obviously, I will be better off economically by not investing in these robots. That is, investing these savings each year for the next 9 years produces a future amount that is less than if I took that $2,045,000 and invested it elsewhere at my minimum attractive rate of return, would result in a greater future amount. Now, notice that the difference between these two numbers is only about 1.4%. They're very, very close. What that means is, bear in mind that these are estimates. Now, our estimates of what it will cost to purchase and install those robots is probably pretty accurate. We're talking about estimates that occur today. Trying to estimate those net savings, though, over the next 9 years probably is a lot more difficult. That is, our certainty about those numbers is not nearly as good as it probably is about that initial investment, which means in making this decision, one might want to go back and assure oneself that these numbers, in fact, reflect as accurately as one can what the true monetary consequences are involved in this choice. This is basically beginning to address the notions of uncertainty, and we'll talk about that more in a lecture later in the course. But for now, assuming that these cash flows are accurate, it would suggest that even though they're only a small fraction apart, theoretically what it says is you're better off not investing in those robots and, in fact, taking the $2,045,000 and investing it elsewhere. Let's be sure we understand what these numbers mean. Again, the $4,752,800 basically means if I take and invest in these robots, I would accumulate by the 9th year an equivalent sum of almost $5 million. As an alternative, I would give up that cash flow stream and invest in the cost series, and I would end up with this cash flow stream. Let's summarize this lecture. We began by talking about a fundamental choice. That is, it's a decision between benefits and costs. Every decision has some benefits and some costs. And the question is, do the benefits exceed those costs or not? We then developed a more formal approach and some notation. We mentioned an economic decision criterion is comprised of two components, a measure of worth and a decision rule. We introduced the notion of a minimum attractive rate of return, that is, an interest rate at which you can always invest. And the role of the minimum attractive rate of return is to help set the standard by which we will compare our opportunities to determine whether they are economical or not economical. And then we introduced some more notation. We let A, J, T represent a net cash flow, and that net cash flow could be divided into its component benefits and costs. And then we introduced a very basic decision criterion, prospective benefits and prospective cost, and that means basically find the future amount of the benefits to the future amount of the costs, or equivalently find some present amount of the benefits and compare that to the present amount of the costs. In upcoming lectures, we're going to introduce a number of other economic decision criteria. Fundamentally, they are all based on these same concepts. The manner in which they will express economic value will be different, but fundamentally, they are all based on these concepts.